subtraction, this is actually a really tricky one because the common denominator here is not a normal situation, which is, I guess, why I wanted to show it to you. Here, there's no factoring to be done really, but the top and the bottoms here, x minus 1 and 1 minus x, are so similar that you could do it in an easier way. I'm going to show you the two ways. So what I would expect to have happen, probably most students would look at this and say that the common denominator is x minus 1 times 1 minus x. Okay, and if I did it that way, there is another way to do it. But if I do it this way, let's kind of see how it works out. So this one is missing 1 minus x, and this one is missing 1 minus x. This one is missing x minus 1, x minus 1. So I do that. Now the bottom is the same. I have x minus 1 times 1 minus x. And on the top I have 2, 1 minus x minus 1, oops, x minus 1. And I end up with that there. And I would expand it and simplify. So that's 2 minus 2x minus x plus 1 over x minus 1, 1 minus x. Okay, now if I look there, what I end up with, so this is the same steps as before. It's exactly the same as adding. It's no different. Okay, now if I simplify what's on top, I have negative 2x and negative x, which makes negative 3x. And I have 2 plus 1, which is 3. Now, what becomes really important in this situation is that you notice something about the top. Okay, it's important that you notice on the top here that the top can be factored. What could I factor out from the top there? 3, sure. So if I factor out a 3, I'll get negative x plus 1 over x minus 1, 1 minus x. Now, negative x plus 1 is the same as 1 minus x. They're just in a different order. So you would have to notice that you can cancel that off to get 3 over x minus 1. And your non-permissible here would just be 1, because that's the only one. These would both be 1. Okay? So you'd have to notice that you could cancel that off, which is a little bit tricky. The other way to do this problem that wouldn't require that, okay, which is something I want to talk about here, is if you look at the original problem, if you realize at the beginning when you start, you might not realize, but hopefully you would, is that those two factors in the bottom are actually really close to the same. Okay, x minus 1 and 1 minus x are very, very close to the same thing. You can turn one of them into the other very easily. If I take x minus 1 and I multiply it by negative 1, if I just do that, I get negative x plus 1, which is the same as 1 minus x. Okay? So if I multiply one of these terms by negative 1, what I'll end up getting is the same factor on the top and the bottom. So if I start with 2 over x minus 1 minus 1 over 1 minus x, if I just take one of them, it doesn't matter which, if it's the first or the second, but if I take one of them and times by negative 1 on both the top and the bottom, I end up with negative 2 over 1 minus x minus 1 over 1 minus x. Now, that is the same as negative 3 over 1 minus x. And that's also an acceptable answer. They're only different because of the negative. That's equivalent to 3 over x minus 1. Okay, they're equivalent to each other. So that one could be done two different ways. I would expect most people to do it the first way, to be honest, just because it's more like systematic. But you would need to realize at the end that you can factor and simplify. So please, at the end of a problem, make sure that you factor and simplify if it's possible when you're adding and subtracting. Let's just dividing. So when you're multiplying, You still factor first, but you're going to have to factor a lot more usually. So here I factor everything. Okay, so what does x squared minus 9 factor to? X plus 3, x minus 3. So everyone should be able to spot that difference of squares. There will definitely be at least one difference of squares in the quiz tomorrow. And I still have a few people who are asking me every time they see it. Or I guess maybe they're not seeing it very often. It's probably they're not really doing their work. Okay, on the bottom we have 6x plus 24. What factors out of that? 6. And what will be left in the brackets? X plus 4 times 10 factors out on the top, so it'll be 10 times x plus 4. And the bottom there has already been factored for us, so we don't have to do it. Don't expand it out. Now with multiplying is much actually easier than adding and subtracting, because as soon as you factor, you cancel. What I hate to see though is that students usually once we've learned both, they'll do a multiplication and suddenly I'm seeing common denominators and they're like trying to find common denominators and they're doing all this stuff. Don't do that. That's just for adding and subtracting. Multiplying is you factor, then you cancel. It's much easier. So we right away can start canceling. What cancels here? X plus 4 and x plus 3. Okay, so I'm left with 10 x minus 3 over 6x. What else can be done there? Divide it by 2. So I divide both the top and the bottom by 2. Okay, to get 5x minus 3 over 3x. Okay, and I write down the non-permissibles. So for multiplication, the non-permissibles come from every factor in the bottom that involves an x. So for x plus 4, the non-permissible would be negative 4. For x, it would be 0. And for x plus 3, it would be negative 3. And that's it. Okay, multiplying is easier than adding and subtracting. So hopefully you don't mess it up and you don't try to do weird stuff. Like just keep really simple in multiplying. You just factor, cancel, simplify, write your non-permissibles. Okay, let's just do one division. And then we'll have some time to practice. So here's a division problem. It's a little crazy. Okay, so division is just like multiplication, except what do you have to do? Flip the second one. So when I do it, all I do is when I'm doing my factoring, because you always have to start off by factoring, I flip the second one as I'm doing it. So here where I have 2y cubed and negative 4y squared, what's a common factor that I can remove from 2y cubed and negative 4y squared? What? 2y squared. Yeah. So I have 2y squared. Left in the brackets, I'll have y minus 2. Okay, on the bottom there, I will have 3y come out, and I'll be left with y minus 3. And then I change this to a times, and I right away flip it. So I'll put the top on the, or the bottom, sorry, on the top. And that one's already been factored for us again, so it's awesome. Okay, and then I have y squared minus 4, which is what? Y plus 2, y minus 2. Perfect. Okay, now this is actually a great time to take a chance to do your non-permissibles, even though it's not at the end of the problem yet, because it's all clean. With division, it's important to remember that everything on the bottom counts, but also the top of the second fraction counts. The reason for that is because we had to flip it. So at one point it was in the denominator. Anything that's ever been in the denominator has to be included. So there's a ton, sometimes there's like 5 or 6 non-permissibles in a division problem. So here it's 0, 3, 2, negative 2, and 3 again, so you only don't include them twice. Okay, so it's that. And just doing that at some point, like you just have to have it somewhere in the problem, right? Just list it. Even if I don't ask, you should be doing this, but I will make sure I always ask. Okay, so even if it doesn't say state the non-permissibles, you should be. But I always try to, just to remind people. Okay, now we just look at what cancels. So what's the same on the top and the bottom? A lot. Y minus 2 is the same. Y plus 2 is the same. Y minus 3 is the same. And most of you are then taking it down, which I'm fine with. I think this is good, doing it in steps. Most of you are then simplifying it to this. and then looking at it, which I think is great. It can be further simplified here, though. What can be removed from both the top and the bottom? One y. So, and I see a lot of you doing this, which I think is totally fine. However, it makes sense to you is great to me. But making sure you do take a moment at the end to make sure nothing else comes out. So this whole long thing simplifies to just 2y over 3. And so you know, the quiz doesn't have any multiple choice, but so that you know, this would be equivalent, if it was a multiple choice problem, that would be equivalent to 2/3 y, like that. Those would be equal things, and sometimes it might choose to write it that way instead. They're exactly the same though. Okay, so don't let that freak you out if you end up seeing something like that. It's the same thing written different ways. Okay, so